Hello everyone, welcome to another base knowledge video, and for the third week in a row we are doing chemistry. Last time and the last time we talked about elements. Last week was about the alkali metals and last week about halogens. However, we're not doing anything else until we finish this lesson about the periodic table. Next lesson will be very exciting since we will go through the reactivities with water which can be seen hidden in the periodic table. However, before we do that, we have to get some basic stuff, which, interestingly, looks completely different from what we're going to learn next: the atmosphere. And before I start the video, I'd like to say that I hope you can support our channel because we are now doing more and more frequent updates. And please subscribe for more. We are nearing 10, but I've said that for nearly a month. Anyway, let's get started. So the atmosphere now as we know it. Firstly, it has 70 to 80% of nitrogen, which is N2. It also has about 20% oxygen. And finally, it has less than of other gases. The other gases are mostly argon or noble gases. Noble gases are the gases on the really far right of the periodic table, beginning with helium and neon, krypton, argon, xenon. So that's the atmosphere now, but the atmosphere wasn't always like this. Before we had a complete different atmosphere. Let's dive in. The history of the atmosphere begins with 1 billion years after the formation of Earth. 1 billion years after the formation of Earth. This time, actually, Earth didn't look at us now. There was no plants, there were no animals, there was not too much oxygen, and stuff like that. So at that time, there were dry soil. That's one thing to point out. Huge amounts of volcanic eruptions. Way more than they are today. Like, today, there may be just once every 10 years or so. And 10 years is actually one of the smallest numbers. But before, it was more and more frequent due to the tidal acceleration. That's physics stuff. We'll do that later. And also, Earth would look like Mars or Venus now. Like Mars and Venus, they are quite toxic. Venus actually has a surface temperature of 286 degrees. Wow. And Mars, highest recorded temperature of Mars is only 26 degrees compared to the 52 on Earth. And winters in Mars can drop to negative 164. Which is actually the record, but the average winter in Mars is negative 32, which we don't want. There is a theory that there was life on Mars and Venus before there was on Earth, since they are all in the habitable zone of our host star, but we are not bothered that. Also, the gases in atmosphere. Sorry, I can't type. 1 billion years ago. So firstly, there was large amounts of CO2. That's something. And then we have H2O. That's water. And we also have nitrogen. And there were smaller concentrations or smaller amounts of CH4, which is methane, and NH3. A thing to point out is that we do not have CO2, CH4, and NH3 in large concentrations now. Neither do we have H2O hanging about in the atmosphere. We do not have lots of hydrogen, although we do have oxygen, which is the second abundant amount in the atmosphere, as shown here. So this is the first part, but didn't I say that the Earth's atmosphere had changed in a positive way? Yes, and now it is the second part. Oceans. Oceans played a good part, although not a significant one, in helping Earth get the atmosphere. So the H2O, which is water, in the atmosphere condensed like rain and formed the oceans. So specific progress, I'm not going to tell you the specific process in this. We will probably do that in biology very soon. And this, the H2O trapped most of the, is some of the sea carbon dioxide in the atmosphere and left it as sedimentary rock, which contains oil and gases we use today for powering our stuff, such as our cars, our planes, even providing electricity, etc. So this is where oceans play their part. But didn't I say this is not the end? Of course, the third part, and the most important one, plants. And that is the real reason we have our atmosphere now. The plants, algae, green plants, and green plants. They started about 1 billion years ago. BY is billion years. Just a quick note. They used photosynthesis. Although we didn't talk about photosynthesis of this started our channel, yes, because we have so much to cover, we'll do that in biology for sure. The equation, as you can remember it now, is CO2 plus H2O equals glucose plus O2. So what are those things? Of course you know carbon dioxide, CO2. Water is H2O. But what is glucose? Glucose is sugar. And the photosynthesis is actually what a plant does to create its own sugar, which is its own food. O2 is oxygen, and that's it. The plants release oxygen and trap CO2, which is a good thing because there will be a decrease in CO2 because of this. But you may ask, what if the plant dies and the CO2 just goes back to the atmosphere? No, that does not happen. When a plant dies, its body falls to the sea floor. There it is buried. The carbon in it is trapped. This also forms sedimentary rock, which provides fossil fuels we use today. So that's the whole thing. What I wanted to ask is what the final conclusion is: what a plant makes using sedimentary rock. So that's an easy question. You probably know the answers. They're crude oil, carbon gas, and also limestone. Just a reminder, These are all made of different plants, but for GCSEs, you do not need to know what plants make what, just that they can make these things. Okay, so that's everything you need to know about the atmosphere. I wanted to add a point about global warming too. Although there are abundant amounts of carbon dioxide in the ocean, which are fossil fuels now, it is important to note that these are not infinite. They are run out by someday. That's why we need to use more environmentally friendly resources, such as, for example, water power, hydropower, nuclear fuel, etc. This could be in another biology session, or physics, or chemistry actually. I see this as a really fun topic. We'll do that after we learn about all the basic stuff, such as isotopes. I hope we can go and look forward to it. Okay, so that's everything you need to know about the atmosphere. If you have any questions, please message me in the comments. If you have any suggestions about what we should make on videos, also please write in the comments too. We are eager to hear your views about this. Thank you and bye.